This paper is titled Column Store versus Row Stores. How different are they really? It's a 2008 paper. To summarize, column-oriented database systems perform significantly better than traditional row-oriented database systems on analytical workloads, which is generally attributed to column stores being more I/O efficient for read-only queries, since they read from disk only those attributes accessed by a query. The simplistic view leads to the assumption that one can obtain the performance benefits of a column store using a row store either by vertically partitioning the schema or by indexing every column so that columns can be accessed independently. In this paper, it's empirically demonstrated that this assumption is false, and primary performance of column store databases comes from techniques like vectorized query processing, compression, block iteration, and efficient join algorithms. There are three primary contributions of this paper. The first is emulating column store in a row store doesn't yield good performance results, and a variety of good techniques like index-only plans, bitmap indices, etc. do little to improve the performance. The second contribution is a new technique called indivisible joins is proposed to improve join performance in column stores. The third is key techniques contributing to column store performance on warehouse workloads are late materialization, compression, block iteration, and invisible joins. The paper uses star schema benchmark, SSBM, to compare the performance of C-store and the commercial row store. SSBM is a data warehousing benchmark derived from TPC-H. Unlike TPC-H, it uses a pure textbook star schema. The paper makes following conclusions. First, attempts to emulate the physical layout of a column store in a row store via techniques like vertical partitioning and index-only plans do not yield good performance, which is attributed to high tuple reconstruction cost and high per tuple overheads in narrow vertically partitioned tables. Second, paper is not saying that simulating a column store in a row store is impossible. A successful column-oriented simulation will require system improvements like virtual record IDs, reduced tuple overhead, fast merge joins of sorted data, run length encoding across multiple tuples, and some column-oriented query execution techniques like operating directly on compressed data, block processing, invisible joins, and late materialization. The top three reasons why a column store is able to process column-oriented data so efficiently are late materialization improves performance by a factor of 3, compression provides factor of 2 on average and an order of magnitude on queries that access sorted data, and invisible join improves performance by around 50%. Now let's give this paper a PS score. On readability, it gets 9 out of 10. It's fairly easy read and well-written paper. On length, it gets 8 out of 10. As it's around 14 pages and could have been shorter. On reproducibility, it gets 10 out of 10 as the findings can be reproduced. Industrial value, I'll say it's 9 out of 10 as it surfaces a lot of interesting performance techniques in column-oriented database systems. On learning meter, I'll give it 9 out of 10. I learned a fair bit about performance characteristics of row and column-oriented database systems. So the final PS score is 9 out of 10.